All right, with the trapezoid, if you remember from our family tree, where the trapezoid was located, it was located in between the parallelograms and the kite. Why was it located in between those? Because it didn't have two pairs of opposite sides congruent, didn't have no pair, it had one pair of parallel sides. And that's all I got for you as far as a trapezoid goes. That's all I have. One pair of parallel sides. What we're going to focus our attention on is just not a trapezoid, but the souped up version, the 2.0 version, which is an isosceles trapezoid. All right, so let me talk about that one right now. In an isosceles trapezoid, remember in a trapezoid, you only have one pair of parallel sides. Well, the sides that aren't parallel, they're going to be congruent in an isosceles trapezoid. And I do not want you to refer to them as the non-parallel sides. We have a name for the congruent sides, and they are called legs. All right? Okay, so that's only in an isosceles trapezoid. So the congruent sides are called legs, and there are two properties I think you need to be aware of. One is base angles congruent. Now, if I say base angles to you, where would you mark those on this diagram? Base angles. Where would you mark it? Probably on the bottom, I'm assuming. The two on the bottom. And you are correct that these are referred to as base angles, but there's also another pair. The top two are also called base angles, and they are also congruent. Okay? Base angles. Now, if I said this now, opposite angles, what do you know about them? Good. Not congruent. We're moving. We're moving. Not congruent. Anybody want to get more detail there? Supplementary. Yes. Opposite angles are supplementary. All right. Good. And then finally, the other property other than the base angles being congruent I need you to be aware of is that the diagonals in an isosceles trapezoid are congruent. I am not saying anything else about them other than they're congruent. So don't assume what? That they bisect each other. Don't assume that. It's not true. They are equal in length, and that is it. Those diagonals. All right? Questions about the old trap? Go ahead, Bill.
Oh, wait, no, never mind.
You sure?
Yeah, I'm sure.
Good idea. You guys are starting to learn a little bit. All right? Do I really want to ask this question? Or is it going to be just roasted material? All right, good job. All right, let's move it on. Okay, finding some values of x using the properties now. One, I set you guys up pretty easy with one. I hope anyway. It's an isosceles trapezoid, and I gave you the value of the legs. So anybody want to come up with an equation for me? Let's do this 10.
3x minus 3.
There you go. The two legs are always equal. So that x minus 1 was just in there for show. Hopefully you didn't fall into the trap there. And then when you're ready, how about the value of x? 10 again. 4. Yep. I don't find the value of the variables. Okay, that's all I have to do. All right, a little bit tougher in 2. You'll see I have an x and a y. And we just went over, hey, the base angles are congruent, right? But do I really want to set y equal to 6x plus 20? Absolutely not. So look at the other angle that's labeled with an x, and that's 4x. If you go back and take a look, what should I know about those two angles right there? They're not opposite. I guess I can call them adjacent or consecutive. 13. 4x and the 6x plus 20. They're not congruent. They are supplementary, yes. And hey, just before, don't solve. Just focus in real quick because this is an honors level here. Doesn't matter if this is a trapezoid or not. These are parallel lines, right? Dig deep, dig deep. What type of angles did we call these during the parallel lines unit? Same side interior, and what did we find out about them? Supplementary. So you could also do it that way. All right. So go ahead, solve for x for me. X equals, what is that? It's an 8. Here we go. What do we got? 12?
16.
16. There's also a y, though, isn't there? So now that I know is x is 16, I'm going to ask for a plan to find y. To find y. How can you use that 16 to find angle y? 16. Huh.
Well, you can plug 16 in for x and 4x.
Okay, into 4x? I'm listening. There's multiple ways, Zach, so I'm listening.
Well, actually, I just realized that you should probably do 6x.
So 6 times 16. Why that one, Zach?
Because they're base angles, and that means they're equal.
Good. So 6 times 16 plus 20 is going to be equal to y because base angles are congruent and isosceles trapezoid. And Zach, when you're ready, what'd you get for y? Never mind. Never mind. Everyone's IQ is going to stay right where it is. 10, what do we end up with?
116.
116. Okay. Everyone all right? Okay, let's get a little honors level going now with number 3. Finding the value of x. Well, this is an isosceles trapezoid based on the markings. So what are the length of both legs then? 13. So that one's 13, right? Oh. What type of triangle is this? It's a right triangle. I could almost do what to find x? To find x. Pythag, right? But I kind of need that little piece there to do Pythag, right? I can't do Pythag on this. X squared plus, what are you going to put, a question mark? All right, I don't know. I got to find out what that is. Thoughts on how to find out what that one is. And remember, I know this base is 34. This base is 24. What's up, Alyssa?
34 minus 24 divided by 2.
Okay, well, why are you dividing it by 2? Where's that coming from? You're correct. I'm just trying to feel the explanation here.
Because there's 2 sides.
So you're saying right now, and everyone else help each other out. What am I going to call this? We have a fancy vocabulary term that starts at a vertice perpendicular to the opposite side. That's an altitude, right? If you draw in the other altitude on the other side, look at what you create. 2 right triangles that are congruent, and what's in the middle here? A rectangle, yep. So that would be 24, meaning how much is left? 10 to divide up evenly between those 2 congruent parts. So what's each piece here? 5 and 5. Okay. Now I can do Pythagorean theorem. Yeah, Zach.
Could you use cosine on
Cosine? What do you mean by You're going to have to further explain to me.
like cosine adjacent of hypotenuse? So like cos 90 equals x over.
Okay, I have 2 questions. One, it's a response. One's a response, and the answer is no. Because you can never use a right angle if you use cosine. You got to use a different one. And 2, where did those words come from?
I take principles in engineering.
Okay, all right, that's fine, because that's something we do later on in the year.
Yeah,
We introduce those topics.
I didn't realize you couldn't do it.
You cannot go from a right angle. You have to go from a acute angle. Okay? So everyone's like, what are these 2 talking about? I might as well be talking in German to them right now. You'd still understand it the same. 5 squared plus, what's my b value here? X or the 13? Which one is it? X or the 13? What's the other leg? X. And the hypotenuse? 13 squared. Yep. So go ahead. I'll give you a second. It should come out to be an integer. And the reason I can't go from the right angle, because if you say, where's the adjacent side? Well, I can pick either one. Okay? 12, what do you got for me? X equals,
12.
look at that. This random number generator is not joking around. Had 16, called on 16, 12, never mind. I'm just the only one that's impressed by that. All right, here we go. Algebra, that was fun, right? Fun's over, everybody. Statements, reasons. Let's go. Statements, reasons. How do I prove a figure is an isosceles trapezoid? This is going to be fun. Go ahead and mark your diagram, highlight the parallelogram like we usually do. If you want to do that or not, that's your call. I got these two angles are congruent, and I have a parallelogram I'll highlight. We ready to do this together? Okay, notice how to prove an isosceles trapezoid. I've listed two different methods. Both methods start with what phrase? If it is a... So guess what we're doing first? Proving it a basic trapezoid. That's our goal first. Prove it's a basic trapezoid. And what did we go over at the beginning of class? What do you know about a basic trapezoid? One pair of opposite parallel sides. So I need your help right now. And you have enough ability to do this. Prove DC is parallel to AB. So I could show it's a basic trapezoid. How in the world am I going to get DC and AB parallel? You have enough info. It's a parallelogram. There's a hint. Anywhere you want me to start with this. Let's do this. 17. Hi.
You can say that DC is parallel to AB because parallelogram implies that opposite sides are parallel.
Thank you. Michelle got you DC and AE. How can you make that go from AE to AB now? How can I make that go from AE to AB? By using a theorem that says 20. So DC, not only parallel to AE, but if I extend it out to AB, they're also parallel. So extensions of parallel lines. Thank you. So parallel lines are parallel. Nice job, everybody. You ready for the bad news now? It's still not a trapezoid. Here's why. Couldn't that still be a parallelogram? That could still be a parallelogram, right? One pair of opposite sides. That's the parallelogram, right? One pair of opposite sides parallel. Read up top. Not only do I have to prove one pair of opposite sides parallel, what do I have to do with the other pair? Prove them not parallel. How am I going to do that? All right. Well, unfortunately, I'm not embarrassed, but this is the least mathematical thing you're going to write down for me to show why they're not parallel. All right. If I had given everyone straight edges right now and said, make DA, the other two sides, make DA and CB longer, what would they end up doing? Can that happen for two parallel lines? No. So we're going to say now that the other pair, DA and CB, we're going to say they are not parallel. And yes, this is okay to write. No, even that's a little less than what I'm going to write. They will eventually intersect. All right, they will eventually intersect. Now what do I have? I definitely ruled out that it can't be a parallelogram anymore, so it's got to be a trapezoid. So ABCD, let me write it in the correct order, is a trapezoid. Thank you for not doing it. Every year I get a kid who abbreviates trapezoid, TRAP, and they're like, oh, ABCD is a trap. And you're not funny. Just funny looking. All right. Somebody brings the cool kid to school. Yep. Why is it a trapezoid? What's a good reason? Why is it a trapezoid? 18?
It's a trapezoid because one pair of opposite sides parallel.
Okay, let me write that down.
Okay.
One pair of opposite sides parallel. And you were going to continue because that's not good enough. And?
The other pair not parallel.
Good. There you go. Thank you. You have to add in that the other pair are not parallel. We're still got to make it a what, though? Okay, so everyone's good on how to show it's a trapezoid, if that's ever asked for you. Now, how do I make it isosceles? Ready? One of two ways. Take your trapezoid and show me the legs are congruent. Or take your trapezoid and show me a pair, just one pair, of base angles are congruent. I will let you know in this proof we can do both. It's just a matter of what you honors kids want to do. Take this trapezoid, make the legs congruent, or prove a pair of base angles are congruent. Do we have a preference in here? I certainly do, but I'll listen to you guys. Thank you for saying the legs. Thank you. Yes, you can prove the base angles. It's dealing with corresponding angles and a couple substitutions, but we can go with the legs. I like it. Okay, so I'll turn it over to you. How are you going to get DA and CB congruent? You haven't sniffed a couple of the givens yet. You haven't sniffed a couple. What are you going to say back there, Maeve?
That CB is congruent to C because opposite triangle,
Isosceles triangle, across from the congruent angles, congruent sides. I like it. So CB will be congruent to, what's that? CB, CE? In a triangle. This stuff never goes away, does it? Congruent sides across from congruent angles. All right, where's Maeve going with that? Where are we building here? Because now I have that. Where are we building? What else should I know? 17. Is it? Be confident, Michelle. Come on. Why? Still don't have the two I need. How do I get the two I need now? Finish cleaning this up with 17 again. Substitution. Whew, 9 steps, huh? Feeling good about yourself. Now it's a isosceles trapezoid. Yeah. ABCD is an isosceles trapezoid. All right, need somebody to be big here. Why is it an isosceles trapezoid? Be detailed as possible. 4.
because it's a trapezoid.
Good start. Telling me it's a trapezoid with what?
The legs congruent.
With congruent legs. Perfect. Implies isosceles trapezoid. You guys are good. Not bad. What do you think about that one, Grace? Okay. All right. Anybody else want to chime in? Good choice. We ready to move on? I prefer not to do this one, just because I don't think it's going to improve us anymore. I'd rather go to the graph right now. Yes, since we have one coming up tomorrow. Just reminding ourselves of our slope and distance formulas. And this one's not too bad anyway. Anybody big plans over break? Okay. Anybody plan on winning the spelling bee Friday, huh?
Don't draw like sausage.
You gonna be participating, Zach?
Sure.
All right. No, it probably should be when the staple remover was invented. I don't know. Google math terms and see what you think are the toughest to spell, because those are the ones I probably picked. Get a math book or any algebra, geometry math book and look in the glossary and see which ones are tough to spell. Oh, you know, supplementary, isosceles, all going to be on there. Complementary. There's going to be some easy and some tough ones. It'll all be random. Okay, let's get to this one so we can finish this off strong. Prove it's just a trapezoid. First thing we need to prove, one pair of opposite sides. Parallel. What's formula am I going to need? Slope formula. Yep. So number one. And it's nice to graph because you can probably visualize which two we're going to prove parallel. Probably, bless you, AB and DC. So let's compare their slopes. AB, what do you got for the rise over run for AB? Up and over how many? Up 3 over 6, reduces to 1/2. Is that a positive or negative slope for AB? Okay, so I'll leave it like that. Okay, go ahead to DC. Up and over. Make sure you're doing the rise over the run. Rise over the run. And that should be 5 over 10, which reduces to 1/2. Positive or negative, this slope? All right. What did we just find out about AB and DC? They're parallel. Now, before I go to step 2, not only do I need to show these two are parallel, what do I have to show about the other pair? Not parallel. And I do not want you to write they'll eventually intersect if you got it on a graph. Because what can I show to tell you or tell me that's not parallel? Their slopes are not equal. So while we're on the topic of slopes, let's just keep going. So slope of AD, slope of BC. Might as well just put them all 4 of them in one step. So I'll let you guys figure that out. I'll call on 2 people here in a second to find AD and BC. You have the slope of AD for me. Slope of AD. Hey, 4 again. Over 2. Yep. BC. BC. How about 5? Slope of BC? Slope of BC? Why? Yeah, but it's going downhill now, Alyssa. Yeah, it is. What are you getting? 3 over 6? What's the issue here? Yeah, up and over how many? 1, 2, 3. 1, 2, 3, 4, 5, 6. So it should be negative 3 over 6, right? So negative 1/2? They're not the same. Don't get confused here. They're not the same.
I accidentally labeled it wrong.
Okay.
So I got AB for the other.
Gotcha. Okay, so let's go. What do you know about? Give me a pair of lines and something you know about them. Here we go. 15. Give me a pair of lines and what you know about them. AB parallel to DC. Give me a reason. Slopes are equal. How about the other pair of lines? What do you want to tell me about the other pair of lines while we're here? 11, what about the other pair?
They are not parallel.
So AD, not parallel to BC. Why KC? Huh.
Because the slopes are not the same.
There you go. Slopes are not equal. Again, tomorrow's quiz. Formulas. What did you just learn about the lines? And now, what do you know about the figure? For 3, what do we know about the figure? 4. On fire, Maeve.
ABCD is the trapezoid because it has one pair of opposite parallel lines and non-parallel lines.
Okay, I think I know what you said. One pair of opposite sides parallel. Yep. And the other pair is not. Questions? Oh, here we go.
Like if it gives you that it's like a parallelogram, like before, do you have to say like in like step number 3 that it's like a parallelogram? Like,
If it's already given, you don't need to restate it. Hey, yep.
maybe that little not parallel thing there.
Who uses the phrase thingamajigger anymore? I don't even know if my parents use it. Maybe my 80-plus-year-old grandmother, but uses thingamajigger. Throw that thingamajigger over here. And you're like, all right, I got some choices here. You're just going to pick one. Yes, you can use that thingamajigger. All right. What do we got? What would we call it? Let's see. Mig Jigger? J maybe? I don't know. All right. Thingamajigger? I don't know. Okay. But let me just